Yes, dear students, now I come to the last topic chapter, eddy currents. Eddy, in Hindi, eddy means bhavar, current, dharaएं, circular currents of like water. Somewhere when water flowing and there is a hole, then circular motion of water you might have observed in river and some flow, etc. And we have learnt how to generate induced EMF by different method. Here, eddy currents. What are the currents actually? FOCO. F-O, बड़ी स्पेलिंग नाम ये है. FOUCAULT. FOUCAULT. It was Leon focus or Leon Foucault, the Foucault, German scientist, German physicist. So you should know little about the history, so that we can realize the importance. Leon Foucault discovered eddy currents in 1851. What he discovered? When a piece of metal is placed in varying magnetic field. Varying means changing in magnitude or changing direction or both. Very magnetic. Then many circular electric current, I should say, electric currents were found in the piece. Now, what was his observation? That is another thing. How did he discover all these things? That is another thing. But now we can notice eddy current how? In figure here, this is a copper sheet, and it is allowed to oscillate between the North Pole and South Pole. It is a copper metal sheet. This is a copper sheet here. It is allowed to oscillate between poles. When it comes here, it stops very soon. Oscillation of this metal copper sheet stops very quickly. Why? And when the same sheet is taken having these cuts, slots, then motion become little easier. Why it is so? When it enters the field, the magnetic flux linked with the metal increases, and hence induced current are produced. But induced current obey Lenz law. So this eddy current will be here in such a manner that motion is opposed. And when it is little outside and come into this field in current in one direction, and when it goes out, current will be in opposite direction. So due to eddy current produced here, motion of the magnet of copper sheet is opposed, so it stops very soon. But here it takes a longer time to stop. It means Actually, what is their magnitude of eddy current get decreased. Here, there are free to move like this current. So this effect was discovered by Eddy, Julian Foucault in 1851. And now we have got very wide application of these eddy currents. So why they are going? Because when metal move in magnetic field or a metal placed in varying magnetic field, then magnetic flux linked with the metal changes, and hence due to phenomena of electromagnetic induction, circular currents are produced. So this was about the same effect is there if you place this. Whether you place metallic sheet in varying magnetic field or you move, suppose here, it is a magnetic field, normal to plane go into it, and we take a metal sheet and move it out, then again circular currents are induced here. Since metals are having low resistance, the magnitude of eddy current will be large. And due to that large, heat produced I square RT will be sufficient large, and and metal piece get heated. If the change in flux is fast, I will be very large, and this can produce so much heat that temperature of metallic sheet rises to its melting point, and it will melt. So now eddy currents have got practical application. They are not required somewhere. Means they lose our energy in the form of heat, but somewhere we use. So where to avoid the heat produced, actually we use core of magnetic material in transformer, induction motor, galvanometer. So there, when field changes, so eddy currents are produced. There we don't need them. So we use their laminated core. I will tell you while teaching alternating current, laminated cores. Thin laminae are cut, and all those laminations are placed, separated from each other by lacquer or some insulating material. So I will come later on, but now I tell you here use. So use of eddy currents. Use of eddy currents. Number one, magnetic braking in rail trains. Magnetic braking in trains. You know, train run on the rails of iron. Inside the train we have a strong electromagnet. Strong, but these are rails, and here is you see wheels like this, and here this is compartment, it is moving like this. So inside this there will be electromagnet. When this electromagnet come into action by passing on through this, it produces magnetic field which induces eddy current in rails, and those eddy current oppose the motion, and the train stops smoothly because no mechanical linkage is there. So these eddy currents produce. Have you got my point? Here we have strong electromagnet. When we pass current through this, a magnetic field produce, very magnetic produce, which is inducing electric current in the rails. These are rails here. So those eddy currents oppose the motion, and hence it is stopped. So number one is The one use is magnetic brake. Number two, electromagnetic damping. I just told. Actually, the core of galvanometer or motors are made of some non-magnetic metals over which we have conducting loop wound around it. So when current passing through this, then it rotates in case of motor. So varying magnetic field is produced in the core, and though that varying magnetic field induces eddy currents which oppose the motion, so it will be stopped. Then important use number two, the damping. Number three, induction furnace. You know, we melt the metals, make alloy of metals, or recast the metal in different forms. So how the melting of metal take place? Induction furnace. Induction furnace is cylinder which is surrounded by coils which produce magnetic field. High frequency magnetic field means the direction this way or this way, keep on changing. We pass alternating current from source, and when we pass alternating current, varying magnetic field induced in the furnace. And when we draw any piece of metal, so there are two things: motion of metal piece in magnetic field, or field is also changing. So large eddy currents are produced. Though large eddy currents produce large heat, and metals can melt I square RT. So this heat can melt the metal almost instantly. Takes no time. So these are induction furnace. So uses eddy currents. Then इलेक्ट्रिक पावर मीटर्स, हमारे जो घरों में लगे ना मीटर टू रीड द इलेक्ट्रिकल एनर्जी कंज्यूम्ड, वी यूज मीटर फॉर मेजरिंग इलेक्ट्रिक एनर्जी कंज्यूम्ड. दे आर आल्सो वर्किंग ऑन eddy currents. Actually the eddy currents here is a metal, shining metal disc. So when we increase current here, field increases, so flux increases, eddy current are produced, so it start rotating. Larger the value of current passing through that, greater the speed. So this is power meter. Power meter uses eddy current. Speedometer. You know what is speedometer? We measure the speed of our vehicle. On every vehicle there is a meter which measures the speed. That is also based on eddy currents. Actually, wheel rotates. As wheel rotate here, we fix a wire, and that wire here connected to a magnet, light magnet, which will rotate with the speed of wheel in a drum of metal. When you rotate drum of metal, eddy currents are produced, and the magnitude of current will be proportional to speed, to speedometer. So these are some uses of, you can read the book, different book, but this is important. In every exam, questions are asked in different form. You can see the question banks. And so now in coming videos, I will be telling you numericals problem of electroinduction, which are very simple, but you feel difficult because we people are not in habit of multiplying, dividing. Physics is not the problem. I feel here students are trapped in calculation. Yesterday, good students were there, but they were not able to multiply. They were not able to divide. Problem is that suppose it comes out 0.01 into 51 upon 2.51. So they can't solve it easily. Simply can see there are two decimals, there are two decimals. So there is nothing you can 51 upon 251 and divide it simply. They keep on doing like this is not required. In class 12 now you should be very fast in doing calculation. And it comes by practice. In multiplying, you forget the digit which you want to write. So I have finished this chapter, but numerical problems are still there. I will be solving for you.